Hello and welcome back. Well, if you watched last week's video, I started some steel wheels, and toward the end of that video I said we would weld the wheels in part 2 with my new welder. Yes was nice enough to send me a TIG-250P. It's an AC/DC TIG welder, and I was a little apprehensive on doing any kind of review on it because I'm not a TIG welder. I mean, I've never TIG welded. I've MIG welded a fair amount, and I'm not any good at it. But I was really surprised. I made some very nice welds in very little time, probably about 10 minutes. But anyway, let me show you what we lack on these wheels, and we'll get started welding the wheels. Then I'll show you the welder and demonstrate it. Hopefully I'll have some good welds. Hopefully it wasn't just beginner's luck. But then we'll start working on the welding cart and do some welding on that. And maybe after that we'll demonstrate some aluminum. And I haven't tried that yet, so you'll see a first time try on the aluminum. Anyway, let me show you what we got on these wheels so far. Okay, I'm holding these in place. It's kind of a firm fit anyway. They're not going anywhere. But I got some 3/8 spacers. And this distance in here is 3/4 inch, and this is 1.5 inches, so the little math, the 3/8 spacer centers these spokes in here if I clamp that to it. So I'm just going to clamp that, just like I got this one. Then I'm going to tack weld right there and right here, and then weld these, flip it over, and I may flip it over and then tack weld both sides. I don't want anything to move or warp. I know it's going to warp a little bit, but I want to try to minimize it. Just like that. That's holding it firmly square against that plate. And then I'm going to weld it right there and right there. Here's a few practice welds I did. Just running beads, fillet weld there, butt weld here. Pretty rough looking, but I kind of redeemed myself right there. That's a sweet looking weld. But those are a little better than most of my MIG welds. But I think we can probably make the welds look like that, I hope. Okay, I went ahead and splurged and I bought the foot pedal. The welder doesn't come with the foot pedal. That varies the amperage. But I tried it with their feature, which, and I think all TIG welders, or most TIG welders, have this feature where it ramps up to full amperage with a torch control. You just push that button and the amperage ramps up. You get a gas pre-flow, and then the amperage ramps up to full amperage, whatever your preset is. And then when you let off the trigger, the amperage goes down, and then you got a post flow where gas cools the weld off. And you're supposed to hold the welder on the weld right when you get done, and that gas is supposed to cool it, and it stops oxygen from getting to the weld. Something I forget to do. I'll pull away before the gas cools it off, and it doesn't really hurt the weld significantly, but you can see some porosity in it, and you can see where it's oxidized. But it's all little tricks you got to learn, but it's relatively easy to use. Some of the controls are kind of confusing at first, but I just jumped right in, and I did do some reading on the manual and a little, watch some of their videos they got on the YES website, and a few other videos throughout the internet. Just Google this welder or just TIG welders in general, and it'll walk you through some of this stuff. So I got my gas over here. That was kind of an ordeal. Not that it's hard to get gas, but local gas companies didn't have any bottles to sell me. So, and I finally came up with one. But anyway, let's get started. Maybe I should practice on something. I don't want to mess up my wheels. Okay, that doesn't look super good, but it looks fairly good. One thing I messed up on is I pulled away from the work before I let off the pedal. But I think we're ready to try the wheels. Like I said, I'm going to tack one side and then flip it over. Okay, I dipped my electrode into the molten metal, which is a common beginner's mistake. So let me grind the end of my electrode off and we'll finish up these welds. Okay, now I'm going to make a complete weld right there and right here, flip it over and do the same thing. And I might come back and weld the back side. I don't know, it's probably not necessary. The welding cart's probably not over a couple 100 pounds, so. It's probably hold up a tank. I like it. Yeah, what do you think? You think I should do the back sides? It'd look better, wouldn't it? Let's try it like this. That's really a better angle. Whoop. That wheel moving kind of messed me up, but it's all right. Yeah, I like it. One wheel down, one to go. Hopefully I can get those washers out of there. I didn't think about that. Okay, let's get this thing trued up in the chuck. I'm just kind of eyeballing it against these ledges on the chuck jaws. Again, I'm using the external jaws internally. It seems to work good. Okay, what we're going to do is open that up to 1 inch, weld this into there, and then put it back in the chuck and bore it for the 1/2 inch axle. I was thinking about putting sleeve bearings in there, but I may just go with steel. I don't really see any. It's going to be a low RPM, you oil it once and forget it. That'll be all right. A little bit loose. Okay, welding that is hard with any kind of welder. But I got a way of doing that. It's probably kind of comical, but it works. That right there is a weld positioner. I've got a pulse modulated power supply there. It's variable speed. I can slow it down to wherever I want. I did a test piece, and I can vary the amperage so I don't have to vary the speed. If I need to weld faster, I just turn up the amperage. And that seemed to work pretty good. It's just it's got a rubber belt and a wooden pulley that'll isolate the motor from the TIG, hopefully. And I want that off center because that's going to create the distance from my welding cart. And if it's too long, I can cut a little bit off. We're going to weld that right there. Got myself a stool here so I can be on top of this weld, get positioned a little better. Well, yeah, I wasn't going fast enough. That looks like hell. Maybe I can grind part of that off and fix it. Well, that looks better than the other side. See if I can do better on the second wheel. It may be too fast, but that's better than a meltdown like on the other wheel. One spot there is looking bad. That's as good as it's going to get. Well, let's see if I can fix this mess up. Put some craters on the outside of that round part there. Basically what I'm going to try to do is fill in those craters. And I don't know how well it'll work with TIG, but we'll see. Maybe beautifully. Hopefully. Well, I wouldn't say that's beautiful, but that pretty much took care of it. I might turn that down a little bit on the lathe and that'll clean that up pretty good. That's about as close as it's going to get, which is plenty close. Got a little wobble in that shaft, but it'll be all right. I figured there would be. Well, I'm overall very pleased with the way they came out. Some of the welds, looking at them now, I used too much amperage. But I'm very pleased with them. Not bad for a first try. A lot better than my MIG welds. Gonna paint these up and then we'll get started on the welding cart. Okay, here's the plan. This is the table for my mill, the stand for my mill. And I built a new stand for my mill because it was too short. And I didn't really think it was very stable for my mill either. But it is extremely stout, certainly good enough for a welding cart. But it's going to be a welding cart table combination. And I've got a piece of plate that goes on the top of it. And I've got 4 casters on it, but I'm only going to use 2 of them, and the other 2 will be the on the back side, and will hold the weight of the welding cart. I'm going to put this right here, and then I've got these angle iron brackets that contour the welding tank. Like that. And then I've got to come up with some kind of hold down, like a strap to hold the tank in there. So I don't think that'll be a problem. And I built these, I cut these brackets here, and I'll weld them right there. And the wheels will bolt onto these brackets. And I needed that little offset in there to get the axle at the right height so my cart will be level. But by having the wheels back here, it adds a little bit of stability to the cart. The weight of the tank is directly over the axle. Anyway, that's the plan. I got a shoulder bolt to mount these wheels. I'm going to thread this and then put a lock nut on the back side of it. Okay, these here I'm going to tack very lightly. I should probably be bolting them on, but welding's a little easier. Just in case tank size changes. But I think any larger tank will fit in here. Oh, no ground. Okay, now we got to do some figuring. This welder and tank need to be mounted in there. I've got a piece of plate for the top, but I want the welder in there at an angle. So the back of the welder will sit in that hole. Yeah, I just got to figure out how to do that. The tank won't be any problem, I just got to figure out a way to strap it in there. Okay, I'm going to use this piece of very thick, 3/32 maybe, sheet metal for a pan to set that welder on, and I want it at an angle. But I don't have any way to bend this, so I'm going to have to be creative. Fortunately, I have a arbor press here. It doesn't need to be a real sharp bend. Hopefully this works. Well, hell yeah. We need to come forward a little. Yeah, perfect. Okay. I made that bolt on in case another welder goes in there, or I don't like the angle of it, I can change it. I'd like it if that top was a little bigger, but that's the only piece I have. A little wider where you could clamp stuff on the edge of it. That would be handy. Now I got to build a clamp for the tank. Bungee cord's definitely not going to get it. Yeah, well, I built this little slip mill probably 7 or 8 years ago. I don't know if it'll bend this or not. This is pretty thick stuff. Thick for this anyway. Probably need pliers. I believe that's got it. Put a couple of bends in here, drill a couple holes and bolt it to there, down lower on the tank of course. I like it. That solidifies it pretty good. Well, there it is with the tank on it. I put a piece of wood on the bottom. Right now I'm working on something to hold welding rods. Plus I want to put something to hold the torch lead right here, and maybe something on the other side to hold the grounding lead. And then I'll be done. Okay, let's weld something a little more delicate. I think I was kind of afraid of putting too much amperage on it. Doesn't need much of a weld, really. Well, guess what? I killed the welder. Yeah, believe it or not, I killed the welder. After talking to YES Tech Support, I realized I made a pretty big mistake, and it makes sense. I mean, what I did killed the welder. I didn't realize it would do that. I didn't really think about it, but in hindsight, it makes sense. Let me show you what I'm talking about. So here's how I started out with the welder, and to get a better visual on the display, I moved the welder forward, and when I did, it contacted right there. And then when I welded, the current from the welder transferred to the case. At least that's what we suspect happened. So I'd say that's what happened, 90% sure. But I got a new welder in 4 days. Can't beat that tech support or customer service anyway. Anyway, I'm going to put a wood shelf on there, and so there's no possibility of that happening in the future. And then I'm going to bolt the steel top on here. I got a bigger piece of steel. And then we'll test weld some aluminum and kind of go over the pros and cons of TIG welding and some opinions about this welder. Anyway, let's get started. Yeah, I got plenty of clearance to that. Okay. I've already got some holes in this frame. And I took a felt marker and marked them underneath, and I'm going to drill those holes and then bolt it to the top there. Okay, I got a place to store the torch lead and the grounding cable. Foot pedal underneath. Should be useful. Okay, aluminum welding is not quite as easy as steel. A lot of it is settings. Some of it is how I was holding the torch. But I'm doing a little better now. Let's see what I can do here. Well, for somebody that's professional TIG welder, that's probably looks pretty shabby, but for playing around with it for 20 minutes, I think that looks pretty good. Well, that looks pretty good. Well, overall, I'm very pleased with this TIG welder. I kind of surprised myself. I was able to get a good weld in aluminum and steel in a very short period of time. Now, I did go out on the internet and research, watch some videos. There's many good videos out there. I'll put a link to some of the videos in the description area. But let's take a look at some of the welds I got. There's an early try. Couldn't really complain about that being my first weld. Started looking a little better there. These are steel, obviously. Looks good there. Not quite as good there, but still overall, I'm very pleased with the weld. And here's my first try with aluminum. Absolute disaster. But I went out on the internet and I found some good starting points as straight AC. And that's what I came up with next. I like that. That's excellent. So let's summarize this. Some of the pros and cons to TIG welding. The pros are you can weld most types of metal, including aluminum and cast iron. You got a lot more control. You can weld vertically and overhead more easily. Nice, clean looking weld. Those are some nice looking welds. The cons, the metal has to be clean. I found that out. Both the aluminum and steel really need to be clean, more critical with aluminum. Welders are more expensive, although this one's competitively priced. Slower than MIG, definitely takes more time. And it's a more complex process, there's a lot more variables. As far as YESWELDERS is concerned, the pros, in my opinion anyway, it's full-featured welder for a good price, small footprint for the welder itself, excellent 3-year warranty, and quick problem resolution. I mean, I screwed up that welder and had a new welder in about 4 or 5 days. The cons, poor documentation, no part numbers for consumable and replacement parts in the manual. You can contact YESWELDER and get the part numbers you need and replacement parts, but It's not in the manual or on their, hard to find on their website too. The last thing is the display on the welder, the operating display for all your settings. It's kind of hard to read. Part of it's because I'm old and got bifocals and got to get on my hands and knees to see it, but it could be better and angled upward a little bit. Anyway, that's about it, and thanks for joining me, and be sure and subscribe and ring that bell.